So in this one, we're told that the work function of tungsten is equal to 4.50 electron volts, and that the photon energy, which is HF, is equal to 5.80 electron volts. Now, this is in electron volts. If we wanted to convert it to joules, we'd times it by E, the charge on the electron, 1.602 times 10 to the minus 19. But actually in this case, because this is in electron volts and this is in electron volts, it's probably easiest to leave it for now. So our photoelectric effect equation tells us that the energy on the photon is equal to the work function plus the maximum kinetic energy. And we're trying to work out the speed of the electron, the maximum speed of the electron. So we can get that once we know what the maximum kinetic energy is. Okay, so the maximum kinetic energy is equal to HF minus phi. So that is equal to 5.80 minus 4.50, and that's in electron volts. So this is equal to 1.30 electron volts. Okay, now we're trying to get the maximum speed of the electron. So we've got that the kinetic energy is given by a half mv squared, and we know that that's equal to 1.30. Now this has units of joules, so now let's put this into joules. So if we times this by 1.602 times 10 to the minus 19, then that's in joules. Okay, now what we're trying to do is find V, so let's rearrange. V squared would be equal to this divided by m times 2, but we'll take the square root of that. So we've got 1.30 times 1.602 times 10 to the minus 19. Then we need to divide by m, which is the mass on the electron, which is equal to 9.109 times 10 to the minus 31 kilograms. And this 2, when this half, when we divide by a half, it's the same as multiplying by 2. And then we need to take the square root of that. And so solving this on the calculator, we end up with 6.76 times 10 to the 5 meters per second. So it's going pretty fast once it gets knocked out of that tungsten atom.